Okay, welcome to graphing quadratics. This video will explain how to use or how to graph quadratic equations. We're going to graph these quadratics using two pieces of information. One, we're going to use the x-intercept, so we need to find the x-intercepts. And two, we need to find the vertex. Now, for most of you, you never heard about the vertex, so let's explain that first. The vertex of a parabola is simply the minimum or maximum point. Now, if I have a parabola that goes like this, then I have a vertex, a minimum point, right there. So this would be, it's called the vertex. Now, if I have a parabola that goes the other way, the other way means we flip it upside down. Let's say this parabola, then now here is a maximum point, and that is referred to as the vertex. So depending whether it opens up or opens down, you either have a minimum or a maximum point, and they're called the vertex. Okay. Now, also you'll see here, this is what we call the x-intercepts, where the graph crosses the x-axis, and over here we have the x-intercepts as well, right there. Okay. So we're going to find those 3 points, the x-intercepts, we'll find that first, and then the vertex. And with those 3 points, we can go ahead and sketch the parabola. The reason I say sketch is because with just these 3 points, it's not a very precise parabola, very precise graph, but it gives us a good idea of what the graph of a quadratic equation looks like. Okay, so let's say the quadratic equation that we're going to use is going to be, let's make one up. Y equals, we'll do x squared plus 5x plus 4. Okay? Now, I'm going to start with the x-intercept. So the x-intercepts. Now, for the x-intercepts, we know we need to substitute 0 in for y. If you look back at this graph here, these x-intercepts are points on the x-axis. And when a point is on the x-axis, that means that the y-coordinate of these points is 0. So hopefully it makes sense to you, therefore, that we're going to substitute 0 in for y. So we do y 0 equals x squared plus 5x plus 4. And now we're going to solve it, and we're going to try to solve it by using factoring. So the first step of factoring, greatest common factor. Well, there is no greatest common factor here. Second step is we're going to try to do a special product. Now here, this is a square, so this x times x. This is a square, 2 times 2. So now you just need to check the middle. So I've got 2 times x, and then double it. This should be 4x for this to be a trinomial square. It's 5x, so this is not a special product. So we're going to use a simple diamond problem with 4 up here, 5 down here. And when you solve this, you find that 4 and 1 are the factors. So you get 0 equals x plus 4 times x plus 1. Now, since my product of these two factors here needs to equal 0, then I know for x, if I make the x negative 4, this factor becomes 0. When I multiply a factor of 0 by any other factor, my answer is 0. So x equals negative 4 is one of my solutions. And from here, I learned that x equals negative 1 is another solution, because that makes this factor 0. Multiply this 0 factor by anything else, and your answer is 0. So these are my two x-intercepts. Alright, so we're going to use these two in our graph. Then next, we need to look for the vertex. Now, to find the x-coordinate of the vertex, we have a little equation here we can use as negative b all over to a. And these b and a are the same as we used with the discriminant and the quadratic formula. A is 1, b is 5, and then c is 4, which we actually don't need here. But this way we can find the x coordinate. So x equals negative, we'll fill in something for b there, we'll fill in something for a here. Now if I look back up here, a is 1, b is 5. And now this problem that I picked doesn't come out very nicely because it gives me an x coordinate of negative 5 over 2. So that's the x coordinate of the vertex. Now we're going to find the y coordinate of the vertex. We need to create a little bit of room here. I'll erase these drawings. Now, so this is the vertex still, but this time we're going to look for the y coordinate. Well, we know that y equals, and the equations we're using is x squared plus 5x plus 4. Okay. Now, I know that the x coordinate of my vertex is negative 5 over 2. So I'm going to substitute those in for x in order to find what the y coordinate is. So y equals negative 5 over 2 squared plus 5 times negative 5 over 2 plus 4. So you get y equals, now negative 5 squared is 25, 2 squared is 4, so this becomes 25 over 4. This here, 5 times negative 5 over 2 becomes negative 25 over 2, and then plus the 4 on the end here. Now, I need common denominators to make to add these together. So I'm going to multiply these by 2 over 2. So I get 25 over 4 plus 50, or plus negative 50 over 4 plus, I need to turn the 4 into denominator of 4 too. Well, I can write the number 4 as 16 over 4, because 16 divided by 4 is 4. And now I have all the denominators of 4. So now it's a matter of combining the numerators. So 25 plus a negative 50 is negative 25. Negative 25 plus 16 makes negative 9 over 4. Okay? So now we have the x coordinate, we have the y coordinate. Now we can put those together and we get x coordinate negative 5 over 2, y coordinate 9 over 4, and this now is the vertex of the parabola. Okay, so let's go over the steps one more time. First I found the x-intercepts. We did that by making the y0, factoring, found the two x-intercepts. Then we worked on the vertex. First, find the x-coordinate of the vertex using negative b over 2a. So I found the x-coordinate of the vertex. Then I had to find the y-coordinate of the vertex. So I took the quadratic equation, substitute the x-coordinate of the vertex in for x's, solved it, and I found the y-coordinate of the vertex. Now we have to do is make the graph. So we have a little bit of room right here. So I'll be making the graph in this section here. So let's draw an xy axis, and actually I'm going to redraw that because both my x's are negative, so I'm going to put the y-axis here. It gives me a little bit more room on the left side there. So we have an x-coordinate of negative 4 and negative 1. So 1, 2, 3, and 4. So negative 4 is one x-intercept, negative 1 is another intercept. Then we have a vertex that is negative 5 over 2. Well, negative 5 over 2 is 2.5, negative 2.5. So negative 2.5, negative 2.5, so right about here. Then 9 over 4 is 2 1/4. So I'm going to just sketch 2, 3. So we're going to do 2.5 and then 2 1/4. So right about there is going to be the vertex. And now you just sketch your parabola through those points, where the lowest point here is the vertex. And let's just keep going. And that's how you make a sketch of a parabola using the x-intercepts and the vertex.